Question number 3. Can you cut a pie into 7 pieces with just 3 straight cuts? What is the greatest number of pieces of pie that you can get with the following number of straight cuts? 1 cut, 2, 4, and 5. So we're gonna do 1 cut first. We'll just go through 1, 2, 3, 4, 5 cuts. So if you only have 1 cut, you will get 2 pieces. So that's very easy. And if we have 2 cuts, 1 and 2, we will have 4 pieces, 2 cuts. And if we have 3 cuts, 1 and 2, just as we have seen, remember the 3rd cut, you better cross all these 2 lines, the previous 2 lines, so that will maximize the number of pies that you would get. So I can do a line like this to cross line 1, line 2, okay? So in this case, we have 1, 2, 3, 4, 5, 6, 7 pieces. And so now if we have 4 cuts, we'll get more and more complicated. But remember, the additional line you are adding on to the cuts have to cross all the previous lines. You have 2 lines, you have the 3rd line, and the 4th line has to go through every single one of them. So let me find a perfect angle. So if I have a line that goes through all 3 previous lines, that would maximize the number of pieces of pie that I would get. Okay, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I would get 11 pieces. Similarly, for 5 cuts, it's going to be more complicated. But remember, whatever line that you are adding onto the pie, whatever cuts, it has to go through all previous lines. 1 cut, 2 cuts, 3, okay, let's find a good line. So you see, it will get more and more complicated if I do line like this. So I'm crossing 1, 2, 3. So I have 4 cuts already. I need the 5th one. The 5th one, if I do 1 cut like this, it will cross all 4 previous lines. So let's start counting. 1, 2, 3, 4, 5, and then 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we'll have 16 pieces. You can do any cuts you want, but remember the next cuts coming onto the pie has to cross all the previous lines. Number 4, how many triangles are in this picture? So in this problem, we can sort this one out as how many 1 triangles that we have. So for example, triangle A, B, C, D, E, F by themselves. So single triangles, there are 6 of them. And then we can look at, these are A, B, C, D, E, F. Those are 6 triangles. Now let's find out how many 2 triangles can form a 1 bigger triangles. So in this case, we can see BC can form 1, and DE can form 1, and AF can form 1. Basically, we're looking at this triangle, and this triangle. Okay, so 2 triangles, there were 3. So we can combine also 3 triangles into an even bigger ones. So we can see that this triangle, I use a different color. This one, and this one. So 3 triangles can also form a bigger triangle. So we have more here, and we also have this one. And So a total, there are 6 of these. The students can find this out. I'm making this picture too complicated. So these 3 are A, B, C together, and B, C, D, B, C, D. Basically, you just go through every single vertex. The next one would be C, D, E, C, D, E. The next one would be D, E, F. The next one will be E, F, A, and F, A, B. You go through every single triangle. So there are 6 of those. So also we can have all 6 triangles together. So to form the very big one. So there's only one choice. So total, how many triangles that we see in this picture? We add them up as 3 plus 6, that's 9, 10. So total there are 16 of those.